Potential energy is energy due to position. Work has been put into it because the rock was here, it had no energy, it's just sitting there. Then work gets put in. This guy puts his own energy into pushing the rock up the hill. Now it has potential energy equal to whatever amount of kinetic energy is going to be released. And that energy can do work of some sort. It can knock things down, it can squash things, it can turn a wheel that maybe generates power, something like that. That's the difference between potential and kinetic. Okay, so finish with that last part. I'm going to erase this and start up with our second concept, which is another kind of energy.
Shave that squirrel right now.
Yes? Hang on, Dad.
Yeah, your mustache.
You got grow in for winter.
No.
It keeps you warm.
I don't care if your mustache keeps you warm.
Mr. Arbach, don't you think mustaches keep you warm in the winter?
I don't care.
So I'm growing this bad boy out.
Well, you can barely
Not
see.
interested right now.
We get
Pretty
grow
sick.
goatee. Ethan should grow
He's got
full
stuff.
beard.
Okay, I'm starting up again. I hope that you're ready to start up again. The next thing we're talking about is,
Chemical energy.
you heard the part where I said I'm starting up again. I hope you guys are ready to start up again. Okay.
I'm ready.
Let's do this.
I'm just to remind you, I'm the one getting paid to be up here teaching you guys something. You're now getting paid to be out there irritating me. So let's remember what we're here for. Yes.
Is that stored?
Stored, yes. Chemical energy is potential energy stored in chemical bonds. And that's what we're going to talk about, which is where that comes from. What are some examples of chemical stored energy? Like, for example, battery, okay, right, that's good. Battery is stored chemical energy. But there's even simpler, more accessible examples. That food, right? Food is one.
Dude, you're smart.
Food and what else? What chemical energy? We use it to run machines and stuff like that.
Yes.
Gas, gasoline, fuel,
Diesel
gas, coal, diesel.
fuel. Dude.
Is it DEI or DIE? Diesel.
D-I-E.
Nuclear.
Just say fuel.
Okay. All right, and so yeah, those are forms of stored energy. And what we're about to talk about is where it all comes from. If I was to write a simple sentence here, here's one. The blank.
Do you have to write this down?
Yes. Here's a little separate square. You can put this anywhere you want that it fits right. The blank is the source of all energy on Earth. What is the source of all energy on Earth?
Motion.
Sorry?
Motion?
Nope. Motion has to come from somewhere. So yeah, there is some motion like wind and falling rocks and waves and stuff, but
How long is this word?
3 letters.
Okay. I just need to make my space.
Everything. So think about it. You can start with your food if you want. Here's Guy again.
I like my guy. My guy.
My guy's too tired. He went home and went to sleep.
He hasn't eaten anything though.
Now he's gonna.
Aw, look how happy.
So here's Guy with.
Just chill.
Do we draw our little person with something?
Yeah. My guy's got a piece of fried chicken.
Why is it polka dotted?
Because I don't know, if I color it in brown, I don't know what it's gonna look like. There.
So much better.
There you go. Guy's got a piece of fried chicken. What was the source of that? What was the ultimate source of that energy? He's going to eat that.
That's not even funny.
He's going to eat that, and he's going to get energy from it. But where did that energy come from?
The chicken
The
and
protein.
the meat.
Arbok, just let me
Protein.
eat this pie.
So the protein in the chicken. Let's see if
Am I right?
I could draw
What?
a chicken. That looks more like a fat dove.
Oh my god.
Should we be drawing all this?
You are so good at drawing.
Yeah, should we be trying all this?
It's exhausting.
His legs are a little far up. Yeah,
Yeah.
actually.
No
Oh
back
my
anymore.
god. That
Very that's good.
All right. So okay. So the chicken came from the chicken. No surprise there. But where did the chicken get his energy from?
Another chicken?
No, you're thinking about something different. I
an
think.
egg.
Not from the egg. He's been out of the egg for a long time.
I'm sure you would.
Oh wait.
It's food, right? Okay, it's food.
I'm not.
Sun.
Yes, you're right. We'll get there. You're correct. The correct answer to this question is the sun. And because the chicken had to get his energy from somewhere, and it turns out that even if some of us eat meat, chickens don't eat meat. There are no meat-eating chickens. And so this chicken got his energy. I don't have a yellow marker, so I'm going to use my highlighter.
Corn.
This chicken got his energy from eating some corn.
What if some of them don't eat corn, some of them eat grain?
Well, corn's grain. I'm just saying, chickens eat seeds, they eat insects, chickens eat worms, chickens eat just about anything. Yes?
What if it's not an animal that you are eating?
Well, okay. If it's a plant you're eating, it's still the energy from that still comes from the same place. Why, are you vegetarian or something? Yep. Okay. So you start at this point then. So you can put a corn cob in a guy's hand or a girl's hand or whatever you have drawn there. But so we're down to basically whatever you eat. Ultimately, it comes from a plant source. And if you eat an animal, the animal you eat eventually only ate plants, like deer.
How are animal?
If you eat deer,
words, trace it back that far. How did animals poop?
well, that's a whole different story. I've got answers to that, but that's not the conversation we're in right now.
So what we're
Right now, we're talking about where does the energy for the corn come from, and that comes from the sun. Uh-oh, that's not the sun. Or what that is.
Something special.
Oh, yes.
Alright, well, that's my best shot at the sun.
That is so beautiful. I'm jealous of your drawing, to be honest.
Yep, the sun.
My son's gonna have sunglasses. Beat up.
I got some ugly sunglasses that Steve gave me.
Okay, the question is, there is not a single thing alive on Earth that's energy does not originate from the sun. The sun is constantly supplying the Earth with energy, and if it wasn't for the sun, we wouldn't have a single thing to eat, and that would happen right fast. Easy now.
Can you move over?
I will, but I need to write a couple more things here.
Yeah, weird.
Okay, so yesterday we learned about some chemical notation and chemical symbols because I'm about to throw some chemistry into this mix. What is the process? The process that leads, that allows the sun to give energy to the plant, which allows the plant to give energy to the animals, which allows the animals to give energy to the guy eating fried chicken. We already heard it. Tim, I believe, just said it, or John, I'm not sure which. Photosynthesis.
My God's gonna have some chill.
So the question is, okay, you guys, there's really only about just a few more minutes here, so just stay with me. Photosynthesis, let's take this apart. Photo, the word photo, or the root word photo, does anybody know what that means?
Yeah, picture.
Nope, it means light.
What?
It means light. Photo means light. Greek word, photos, means light. Synthesis means to put together.
Oh, oops, I accidentally did an airplane.
So putting together using light. And what the sun puts together using light is it puts together chemicals from the air and the ground into making sugar. And basically, you've got carbon dioxide from the air that the plant takes in through little openings, actually in the underside of its leaves. Carbon dioxide goes in, and what's the other ingredient that we need for photosynthesis?
Water.
Water, right. H2O from the ground. Plants develop this ability to take water from the ground and carbon dioxide from the air and put them together in a process called photosynthesis, where you have H2O plus CO2 yields. Does anybody know what?
Glucose.
Glucose, right. Sugar. That's why I taught you that chemical yesterday. C6H12O6. I'm going to put a little box around this. H2O and CO2 yields C6H12O6. Quiet, please.
Huh?
Oh my
I say quiet, please.
I'm a little
You're talking. You're not hearing what I'm saying. Other people are hearing what you're saying and not what I'm saying.
Oh, I forgot the video.
If you look here, you guys, and this is really pretty much it. So just stay with me. This is the lesson right here. If you look here, what do we got here? We have hydrogen, oxygen, carbon.
Oh wait, it's the same stuff.
And over here, hydrogen, oxygen, and carbon. It's a chemical reaction that happens inside of plants that allows these things to be combined or synthesized into this molecule. This molecule actually contains energy, because here's the thing. This is the very last thing. Okay, so I've got some water in here. Here's water. Here's carbon dioxide in the air, right? So I could just leave this out here and we're going to make sugar, right? We've got water, we've got carbon dioxide. What else do we need? What else we need? We need energy. So it's energy plus these things. So this molecule basically has more energy than this one. This process here, this is the very last thing. This process here of taking, can you guys see this? I know you probably
I
can't.
can, because I can see right here.
H2O.
Your computer's
I don't know. Here, let me put this down. Sorry. Sorry. H2O and CO2 are what we call low energy molecules. And with photosynthesis, what we do is we add energy from the sun that allows us to create glucose. C6H12O6, which that actually has stored energy in it. That is the lesson. The energy from the sun is stored, literally stored in here, that you can burn this for energy. You can burn sugar for energy in your body, or you can burn sugar in a hot plate or whatever. You can't burn H2O and CO2. You can't get any energy out of those. You can get energy out of this. So when the chicken eats this, what the chicken's eating is the glucose, turns that glucose into carbohydrates, protein, fat, basically so fat, protein, carbs, all of those go to us because the plant is able to produce glucose by using sun energy to make stored chemical energy in the form of a molecule. Alright, so that's definitely a pretty good place to stop there. Yes, sir. Yeah. And I'm gonna post this online.
Look, use that fiber up.
Alright. Alright. Let's stop this.
$5, that pie is yours.
And that pie obviously isn't that good.